Hi everyone, this is Mrs. G.A. and today we're going to talk about arithmetic and geometric series and sums. I have a quick warm up for you guys, so please pause the video and hit play when you are ready to check your work. Alright, so here we know that the third term, or a sub 3, is 3 over 4, a sub 6 is negative 3 over 32. So you can create a system of two equations, which you can see right here. And we can use substitution to help us first solve for r and then a sub 1. So here's our explicit rule, 3 times negative 1/2 to the power of n minus 1, and we can use that to help us find our ninth term, which should be 3 over 256. Alright, so today, instead of focusing on sequences, we're going to be focusing on series. And a series is simply a sum of the terms of a sequence. So a sequence looks something like this. Remember, it's just an ordered list of numbers. So essentially, instead of being separated by commas, now it's being separated by plus signs or minus signs because we're finding the sum of the terms in that sequence. So this is what a series looks like. Now, a series can be infinite, meaning that they just keep going on forever, or they can be finite, meaning they have a specific end point. So there are some formulas we're going to be using today. First, we have the finite arithmetic series formula. For arithmetic series, the only way we can find a sum is if it is finite. If it's an infinite arithmetic series, there's no way to find that sum because the sum would just keep getting infinitely large or small. But if it has an ending point, we can find the sum using this formula. S sub n, which is the sum of the first n terms, is n over 2 times a sub 1 plus a sub n. There's also a formula we can use to help us find a finite geometric sum, and it's S sub n. Again, the sum of the first n terms is a sub 1 times 1 minus r to the power of n over 1 minus r. Again, r is that common ratio, a sub 1 is that first term, and n is the number of terms we're finding the sum of. And last, there is a formula that we can use to find an infinite geometric sum. So this only works in some cases. We can only do this when the absolute value of our common ratio is less than 1. And we'll talk more about this later, but this formula is S equals a sub 1 over 1 minus r. So these are the three formulas we will be working with today to help us evaluate a series, which again is just a sum of the terms in a sequence. All right, so let's look at this first example. It says find the sum of the first 12 terms of this series. So first, it's really important that we determine whether this is arithmetic or geometric. So if you look at the terms, you can see there is a common difference each time we are adding 8. So since there's a common difference, we know that this is an arithmetic sequence. So to help us find the sum, we're going to use this formula, n over 2 times the sum of the first and the last term. So here we want to find the sum of the first 12 terms. So n is going to be 12. So n is 12. We can see that a sub 1 is 16, but we need to figure out what a sub 12 is. We need to know the 12th term to help us find this sum. So I think the best thing we can do is to actually create our explicit rule to help us find that 12th term. So we do need to do a little bit of review for how to create a sequence. So again, a sub 1 is 16. Our common difference is 8. So we have a sub n equals 16 plus n minus 1 times 8. So we have 8n plus 8. So again, we could use this to help us find our 12th term. So a sub 12 is 8 times 12 plus 8, which gives us 104. So that's our last piece of information we need to find the sum of the first 12 terms of this series. So the sum of the first 12 terms is 12 over 2 times 16 plus 104. So the sum of the first 12 terms of the sequence is 720. And there you have it. So you can see that in addition to using our new formula, we still needed to remember how to create an explicit rule for an arithmetic sequence. All right, go ahead and pause the video and give this one a try on your own. All right, go ahead and check your work here. The first thing that I did is I found the explicit rule for this sequence, for this arithmetic sequence, which would be this, which I used to help us find the 20th term of the sequence, which is negative 204. And then that allowed me to find the sum of the first 20 terms of the series. So it's 20 over 2 times negative 14 plus negative 204. So we should get negative 2,180. All right, so I have another one for you to try on your own. This one is slightly different, but please pause the video and see if you can figure it out, and we'll check our answers in just a few seconds. Okay, so for this one, we're still going to be using that same sum formula, the finite arithmetic series formula. However, instead of solving for s of n, we're actually solving for n. So we're told that the sum of the first n terms is 21. We know the first term is negative 6 and the nth term is 12. So we can plug those in and solve for n, and we should get n equals 7. So there are 7 terms in this series. All right, let's try another one together. So here again, we're going to find the sum of the first 9 terms. But first, let's look at this series. If you look at the terms, we have 1, negative 3, 9, negative 27. We know this is no longer an arithmetic sequence. It's actually a geometric sequence because now there's a common ratio. We're multiplying by the same thing to get to the next term. So this is geometric. So we are going to be using this formula. Sum of the first n terms equals a sub 1 times 1 minus r to the power of n over 1 minus r. So let's see if we have everything we need for this one. We know that our first term is 1. We can see from the pattern of the numbers that our common ratio is negative 3. And we are finding the sum of the first 9 terms, so our n value is 9. So for this formula, we don't need to know what the 9th term is, so it's a little different than with arithmetic series formula. So we actually have everything we need to find the sum. So the sum of the first 9 terms is going to be 1 times 1 minus r, which is negative 3 to the power of 9, over 1 minus negative 3. So if we start simplifying, we get 1 plus 19,683 over 1 plus 3, which is 4. So we get 19,684 over 4. So the sum of the first 9 terms is 4,921. All right, so again, I have one for you to try on your own, so please pause the video and give it a go. All right, so go ahead and check your work here. We have everything we need to use our formula. We know the first term is negative 2, our r value is 4, and n is 7. So you plug it into the formula, and you should get negative 10,922. All right, so again, I have one that's slightly different, but I want you to try on your own, so please pause the video and give it a go. So again, we're going to be using that formula, except instead of solving for s sub n, we're actually solving for n. So we'll plug in everything we know from our given information, and if we simplify, we end up getting negative 3,125 equals negative 5 to the power of n. So we haven't yet learned this year how to solve an exponential equation, but this we can kind of do a little guess and check we know that 5 cubed is 125. We know 5 to the power of 4 is 625. So if you try a few, you'll find pretty quickly that 5 to the power of 5 is 3,125. So n would be 5. All right, so now we're going to see if we can find the sum of this infinite series, if it is possible. And we know that this is now an infinite series because it just has the dot, 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 and we're not being asked to find the sum of the first however many terms. So first, let's make sure this is a geometric series because you can never find the sum of an infinite arithmetic series. So if you look to see what our common ratio is, we can see that there is a common ratio, and it is 1/5. As you see, our numerator is not changing, but our denominator is multiplying by 5. So our common ratio is 1/5. So it is a geometric series. And remember, our formula is this, but it only works if the absolute value of r is less than 1. Because we need our terms to be decreasing, and our terms will only decrease if our common ratio is the absolute value of it is less than 1. So when we have something like this, we actually can find this sum. So we're going to plug in the information we know. So our first term is -3, and then we do over 1 minus 1/5. So this, we can actually keep our answer as a fraction. So we have -3 over 4/5. So the sum is just going to be -15/4. I know you might be wondering, well, how is it possible to have a sum of something that is continuing infinitely? And really, so what's happening here is as you continue on, the numbers in your terms are getting so incredibly small, really, really fast, that by the time you even get to the 10th term, what you're adding to the sum is so, so, so tiny. We almost say that it doesn't change the sum. So if you can think of it as going on infinitely, really we're getting so incredibly close to this number, it's kind of like a limit, that we say that there is a sum that exists. So that sum would be -15/4. All right, so go ahead and pause the video and give this one a try on your own. All right, so first we need to make sure this is a geometric series. So if you take any term and you divide it by the term before, you do get the same common ratio, which is 3/4. And then since the r value, the absolute value, is less than 1, we know that we can find this infinite sum. So a sub 1 is 2, we plug it in and simplify, and we should get 8 as our infinite sum. All right, the last thing we're going to talk about, it has to do with our sums. It's just a different notation, a different way to show that we're finding a sum, and this is called sigma notation. So again, it's just a way to write a summation. So this letter is called sigma. It's a Greek letter, and we always use it for to show a summation. So you're going to see kind of phrases that look like this. So when you see something that looks like this, again, we have the sigma, so we know we're finding the sum. To the right of the sigma, you're going to see the formula for the series or for the sequence that we'll be using in the series. So it could be something like this, which is an arithmetic sequence, or it could be geometric, or it could be something totally different. And then on the bottom, we call this the index of summation. This tells you which value we're starting with. So we're starting with the first value in this case, and then the number that you see on top tells you the last value of the sum. So for this, we'd be finding the first 6 terms, the sum of the first 6 terms of this series. So we're going to practice evaluating different series when it's in sigma notation. So let's look at this first one. Here, I can see that we have an arithmetic series. And we can just tell by the form that it's in. This looks just like all of the other arithmetic sequences that we've been working with. So it's arithmetic, and I am finding the sum of the first 15 terms, because I'm starting when k equals 1, and I'm ending with the 15th term. And for sigma notation, it's very common to see different variables other than just n. Sometimes it's I, sometimes it's K, sometimes it's N. In this case, we're using K. So we are going to use our formula. So the sum of the first n terms is just going to be n over 2 times a sub 1 plus a sub n. So again, it's the same formula. It's just interpreting a different notation of this series. So first we need to find what the first term is. And we can do that by plugging it into this, which is our sequence. So 10 times 1 minus 8. So we can see that our first term is 2. And then we also need to find the 15th term because that's our last term of our sum. So equal 10 times 15 minus 8, which is 142. And now we can find the sum of the first 15 terms. So 15 over 2 times 2 plus 142. So the sum of the first 15 terms would be 1,080. All right, let's try another one together. So here, first, let's look at this, the explicit rule for the series we will be using, and we can see that this one is geometric, and we are finding the sum of the first 7 terms. So you can see we're starting with the first and we're ending with the 7th. So we'll use that formula, a sub 1 times 1 minus r to the power of n over 1 minus r. So looking at this, we could plug in 1 to help us find what our first term is. If you plug in 1, we have 5 to the power of 0, which is 1. And so we can see our first term is just 4. 4 times 1. And we can see that our common ratio is 5 due to the form of our sequence. So remember, for geometric, it looks like this. So we can see that r is 5. And we have everything we need to find our sum. So the sum of the first 7 terms is 4 times 1 minus 5 to the power of 7 over 1 minus 5. Then from here, we just need to simplify. And we should get 78,124 as the sum of our first 7 terms. All right, let's try another one together. So here, again, we can look at this and we can see that this is a geometric series because of the form of it, or if you plugged in a few numbers, you would see it is geometric. And since the last term that we're finding is infinity, we're trying to find an infinite sum. So first we need to see if this is even possible. So remember, the thing to check is our r value. And we can see here that our r value is 0.9. So since the absolute value of r is less than 1, this is possible. So we're going to use this formula. And we can see that our first term, a sub 1, is 2.4. So we just do 2.4 over 1 minus 0.9. So our infinite sum would be 24. All right, so go ahead and pause the video and give these 3 a try on your own, and we'll check your answers in just a few moments. All right, go ahead and check your work here. So for the first one, you're using the finite geometric formula. So the sum of the first 10 terms should be negative 341. For part B, we're finding the sum of the first 15 terms, and it is an arithmetic sequence. So the sum should be 145 over 2. And for the last one, it is geometric and it's infinite, so you need to make sure that your common ratio, the absolute value, is less than 1, which it is. So it is possible to find this infinite sum, and you should get negative 3,125 over 2. All right, to end off this lesson, I just have a last challenge problem for us to try together. So this problem, and you see the sigma notation, we see that it is an arithmetic sequence that we're working with, or an arithmetic series. So we know that we have our formula for this, but there is one thing that's different. Notice which term we're starting with here. We're starting with the fourth term, and we're finding the sum of the fourth through 13th term. Now here's the thing, the formula that we have learned for this arithmetic finite series only works for the sum of the first however many terms. So we have to do some strategizing here. If we only want the 4th through 13th term, what we're going to have to do is find the sum of the first 13 terms, and then we're going to have to subtract out the terms that we don't want, which would be the sum of the first 3 terms, because we want to start at the 4th, so we want to subtract out the first, second, and third term. So we're going to have to find 2 sums, and we're going to have to find the difference between them. And again, you just need to be careful here because our formulas only work for the sum of the first however many terms. All right, so let's start by finding the sum of the first 13 terms. Well, first we are going to need to find the first term. So we have 7 times 1 minus 3. So our first term is 4. We're also going to need to find the 13th term because we'll need that for our formula. So our 13th term is going to be 88. So let's start by finding the sum of the first 13 terms. So it's going to be 13 over 2, or n value over 2, times the sum of the first and the last terms. So the sum of the first 13 terms is going to be 598. And then we need to find the sum of the first 3 terms, which is the part of the sum that we don't want, so we can subtract it away. So we do need to find the third term. So 18, so it's going to be 3 over 2 times 4 plus 18. So the sum of the first 3 terms is going to be 33. Remember our strategy to accommodate this kind of different setup. We're going to do the sum of the first 13 minus the sum of the first 3. So our overall sum that we're looking for is 565. All right, that is all for today's lesson. Thank you so much for watching.